Saxon Algebra 1, Lesson 96. Yay, it's our last lesson before spring break. Yay. The topic of this lesson is difference of two squares theorem. This is a perfect example of one of the things I really like about how John lays out his materials. Before he gives us a complicated calculation to deal with, he breaks it down bit by bit and explains all of those individual steps in lessons before he introduces the big new complicated thing. This lesson that we're doing today is eventually going to become one step in a fairly complicated formula that we're going to be using. And you're going to look back on this lesson and go, oh, I understand why he did it that way. Okay? So I'm going to give you just a little bit of explanation. We're going to be dealing with equations today that look like this. A square equals a square. And we're going to be dealing with how to simplify that, right? How do you get to the root of that? John wants us to understand that it all comes from the difference of two squares theorem. We can take this and rearrange it, right? If we subtract q squared from both sides, we'll get p squared minus q squared equals 0, right? That's easy. I just do the algebra and I swim that q over. Now this we recognize. This is the difference of two squares. I said that weird. The difference of two squares theorem. And we can factor this really easily. P minus q, p plus q, right? We've been doing that for a long time. That's just called difference of two squares theorem. And we know that when we see this pattern, we can automatically factor it like this. Sometimes I put the plus sign first. Sometimes I put the plus sign second. It doesn't matter as long as you have one quantity of each. In multiplication, order doesn't matter. Okay, now we know how to solve something like this too. We say either p minus q equals 0 or p plus q equals 0. Because when two things multiply to equal 0, one or the other of them has to be 0, right? So we can move ahead in our solving by saying either this one's 0 or that one's 0. And then we do a quick little bit of algebra here and we get p equals q or p equals minus q. This is the shortcut we were looking for. We want to get in the habit, when we see something that looks like this, our brain takes us immediately to that. I just showed you the proof of how it works. Now, we don't have to think about that anymore. We can just take the shortcut. When we find ourselves with this scenario, we just go straight to here. And that is what's called the difference of two squares theorem. That if you have this, then you have this. So let's look at how that applies to a problem. John says solve, this is what the instruction looks like. P squared equals 16. Oh, okay. That's this form, isn't it? A letter squared equals a number squared. Oh, that's it, exactly. So now we know that P equals 4 or minus 4, right? That's this. And here's a better way to write that. P equals plus or minus 4. Have we used this symbol, the plus or minus? It's a faster way of saying this. This is the answer to this problem. Cute, right? Now, let's make it a baby step more complicated. Solve p squared equals 41. Okay, we see the p squared, and that matches here. But this isn't a perfect square. But, newsflash, numbers don't have to be perfect squares to still be squares. We can always see 41 as square root of 41 times square root of 41. That's true, right? Any number is a perfect square of its square root times its square root. We don't know what that number is, but we don't have to. We can just put that symbol over it, and that covers exactly what we need to say. So for this answer, we can say P equals plus or minus the square root of 41. Oh, that's even easier. We don't have to find, 16, where was it? This one. 16, it kind of jumps into our brain that 4 times 4 is 16. But here, we don't even have to calculate. We just slap a little pig house on it and it's good to go. Okay? And that leads me to our final example. The way that we notate is the word I want to say, but that sounds hard. The way we show our work on this step. Oh, shoot, I did it without thinking. K squared equals 13. When we want to simplify this and get the answer, what we do is we show that we're taking the square root of both sides. See how I did that? In these, I didn't show my work like that. This is better. I want to put a pig house on each side, and then I can write K, because the square and the pig house cancel each other, equals plus or minus square root of 13. Okay, so these are okay. This is better to show that you're taking the square root of both sides and then write your answer like this. This is the gold standard. This is the way we will be working these problems in the future, by showing this step. This is the way I want you to do it in your homework and on the test when I give you a problem from this lesson, which I promise you I will. I promise you 96 will be on there. So remember, I want to see this. I will take a point if you don't show the square, that you're taking a square root of both sides, right? I think that's obvious, right? So I would have just gone back for these. I would do that, and I would do that. Okay? All right, that's enough. 96 is done. Goodbye.